So again, welcome to the online information session. This is for geophysics, which is one of many different curricular areas at the Scripps Institution of Oceanography. We have a number of geophysics faculty here to talk with you. We'll introduce them as they come up. My name is Adrian Borsa. I'm a professor of geophysics. My area is geodesy. We have somebody representing pretty much every part of what we do. Of course, we're a huge faculty who do many things. So what I will do, I want you to know that the chat is yours. Please go ahead. Anything that comes up, questions, you can put them in there. That'll give us some guidance in terms of what we're doing. Later on, we'll have an official question and answer period for you to just bring up those chat questions. I'll refer back to them. But do please feel free to use that and feel free to talk to each other if you want as well. Okay, kicking it off then, our agenda, introduction, we're gonna, that's me right now. I'll get into a little bit more. We're going to have different faculty members talk about some of the research that we do. Dave May will be covering the geophysics graduate program overall. Madeline will be talking to you about the student experience, and then we'll have what we hope is a robust Q&A. A few of us will be staying after as long as you want to be answering questions. So great. So I'm going to kick it off with a bird's eye view of the Scripps Institution of Oceanography. That's all this on the hill overlooking the ocean, and of course there's our Scripps Pier. The buildings that house the geophysics faculty and students are the ones in yellow. This is the Institute of Geophysics and Planetary Physics. We're mostly in that long building that juts out over the ocean, and for you to go to the end of the building, which we do often, and look out during the summertime over that ocean. What you typically see is a wave train. Well, of course, it's beautiful and blue, but you typically see these wave trains coming in from the upper left of this picture, which is west-northwest, sort of northern Pacific, and makes total sense. That's where the greatest fetch. But if you look even more closely, you'll see that some of the waves don't actually move in the direction of the incoming waves. And turns out that there was a study back in 1947 that examined exactly this. So right offshore here, there's an underwater canyon. And the incoming wave train, in fact, refracts certain of those waves in, and you end up with one of the epic beach breaks in all of the world. It's blacks. So part of our DNA turns out to be totally by accident, this the ocean impinging on our coastline and creating this this surf break. But I'm really not bringing that to you to tell you about surfing. It's more that, in fact, the authors who talked about this and discovered it included Walter Munk, who in whose building we're actually sitting right here. So Walter Munk is an icon in oceanography and geophysics. Shortly after this paper was published in the Journal of Geology, he was offered an assistant professorship in the Institute of Geophysics, which was our predecessor. So here's Walter, much younger Walter. He and Harold Sverdrup next to him are no longer here, but it's really important to sort of think back, like what's in the DNA of our institute here? You know, what are the things that made us who we are? And the first one turns out to be Walter Munk's advisor, who was Harold Sverdrup. You might know that name. So from Harold, Walter brought in this idea of, you know, you don't just want to observe the world, you need physics-based models to understand it, and really understood and enjoyed working with data. Well, you know, further along into his career, Walter spent a sabbatical at Cambridge University, Department of Geodesy and Geophysics, in a building called Mattingly Rise. And from there, sort of additionally got an appreciation for physical models backed up by math. But also instrument building. And if you walk around our institute here, you'll see people building all kinds of instruments for all kinds of investigations. And then a little bit at the time, New Jersey was host of Bell Laboratories. And Bell was doing all kinds of cool things in the information technology space. And so that was brought in as well. So, you know, overall, we have this institute that was based on, has a long history. You come to Scripps as a graduate student. The summary here, you will have the opportunity to go into the field. And by field, I don't just mean land. Of course, it's ocean, it's marine. We're on the ocean for just by accident. Collect data. It might be with instruments that you've built or you've helped build. Process and analyze that data using methodologies that you'll learn in class. These are all up to date. You learn a lot from your colleagues. Build these physics-based models to help interpret those observations, and then you work with a wide variety of faculty. It's very collaborative. So that's the sort of big picture of where we are and where you would fit in. I want to quickly say something about the educational structure here at Scripps. So SIO is the acronym for the Scripps Institution of Oceanography. It's very complex, even for us. So here's a little roadmap. You will get this PowerPoint later on to refer to. So our department is SIO. Within it, there are 3 programs. The top one is Climate, Oceans, Atmosphere. Then where we sit is Geosciences of the Earth, Oceans, and Planets. That's the middle one. And then Ocean Biosciences, the bottom. Within these are curricular groups, which are breaking out specific types of study areas. In that orange one, which is Geosciences, there's Geophysics, which is specifically what you're here for. Then Geoscience, which includes a lot of geology and marine chemistry and geochemistry. The institute that we're at, the Institute of Geophysics and Planetary Physics, in fact, is really interdisciplinary, and it touches on many parts of Scripps. I'd say maybe the strongest, well, definitely the strongest geophysics, but geoscience and climate science are really important connections. In addition, IGPP, our institute, also has a lot of connections across UCSD. So School of Global Policy and Strategy, School of Engineering, departments of anthropology and chemistry, and also the San Diego Supercomputer Center. So you're not just coming to sit on the edge of the ocean and do your own thing right here necessarily. Really, we have connections across campus. Finally, the physical place where we are, this is the building, the Monk building back in 1962, right after it was built, for a shockingly low $625,000. We just renovated the exterior for well over $1 million to give you an idea of what those numbers mean. Were you to come as a first-year student, you would be over there where I'm pointing. That little arrow on the left is the Keller, which is German for cellar. A slightly different, so this is the updated version of Monk, and I don't have an arrow, but that same Keller is there tucked underneath this building, cantilevered over the ocean. So it's a pretty epic view of your future, and I'm just going to point out the lunch benches, or the benches on the left. Those picnic tables are where everyone or many people go to eat lunch. Finally, many epic sunsets, and I will leave it at that. Again, any Q&A, any questions you have, you can drop them in the chat or hold on to them. And with that quick thing, I want to now go in. The next piece is our research, and the first piece, the first section is marine geophysics. Ross Parnell-Turner will be giving that. So Ross, over to you.
Hi, thanks, Adrian. So hello to all of you. I'm Ross Parnell-Turner. I'm a marine geophysicist here at Scripps Oceanography. And in a very brief amount of time, I'm just going to give you an overview of some of the work that we do at sea. There's no requirement to go to sea or to work on marine data, but as it's kind of given away in our name, oceanography is a big part of what we do here at Scripps, and there's a large number of us in IGPP and the geophysics program that collect data and analyze processes going on in the oceans. So this lineup here is a taster of some of the faculty here in the geophysics curricular group who do work at sea. And I'm not going to have time to talk about what everybody does. I'm just going to show you a couple of examples. So let's start here with Jamin Greenbaum, whose group works in the polar regions. You're going to hear more about polar research in a moment from Helen Fricker. But this is a photograph of a Korean research vessel that Jamin has been collaborating with, where they're deploying this novel instrument called a rift ox, or a recoverable ice fracture ocean explorer, which is a way to take measurements of temperature, conductivity, and salinity in places that are otherwise inaccessible, like this place, which is called Thwaites Glacier, which is also known as the Doomsday Glacier in Antarctica. And this is an instrument that was designed and built here in this building. So let's go to the next one. So Steve Constable's group does a lot of work on marine electromagnetism, and they host the US's largest pool of marine electromagnetics instrumentation. And they do a whole wide variety of experiments. So on the right-hand side of this slide, you'll see some members of Steve's group deploying an EM instrument. It says here the Goban Spur in North Atlantic. Actually, this is an experiment off Alaska earlier this year. But that funny looking yellow thing with the blue thing sticking out, this is one of the instruments, again, that we designed and built here at Scripps, and is a major part of their research program. And on the left-hand side, you can see an image of some work that was done by a student in Steve's group, looking at using these marine EM data to understand resistivity and the presence of things like marine hydrates and aquifers off the coast of California here in Southern California. The next example I want to give you is Mark Zumberg, who's a research geophysicist who's primarily working on seafloor geodesy. So his group are looking at motions of the seafloor on a very fine scale. And they use all kinds of cool technology, like, for example, in this photo on the right, they're launching a thing called a wave glider, which gives an acoustic telemetric connection between instruments we put on the seafloor, like a transponder, to satellites that we use overhead to provide position and timing information. Okay, next slide. And then lastly, I should tell you a bit about what I do. So my group primarily works on mid-ocean ridges. We use a variety of tools. So on the left-hand side, you can see a picture. This funny looking white thing is the Alvin submersible, which we use to collect data from hydrothermal vents. You might be able to just see a face in the porthole there. That's one of my students looking out of Alvin at a depth of about 2.5 kilometers below the seafloor in the Eastern Pacific. And we're collecting temperature time series data on hydrothermal vents like the one you see in the bottom picture here. And we use robots to collect high resolution maps of the seafloor. So the map on the right-hand side there, that colorful thing, that's a 1 meter resolution map that we created of this study area over the past 5 years or so. Okay, next slide. And we don't just use submersibles, we also have been for a long time leaders in multi-channel seismic reflection imaging. So this image on the right-hand side is an image of a 3D magma body system that's underneath the East Pacific Rise. These 3D images are collected using state-of-the-art vessels like this one here. You see the Marcus Langseth. And actually we have in 2026, we're going to go back and recollect this data set. So we're going to have the first ever academic 4D or time-lapse multi-channel seismic experiment ever done globally. Okay, next slide. And then lastly, my group spends a lot of time working with data that are collected through scientific ocean drilling. This is the drilling vessel JOIDES Resolution, which we use to collect samples and logging data deep beneath the seabed. So if we go to the next slide. So for example, in summer of 2023, we spent 2 months offshore Greenland drilling down beneath the seabed. The graphic on the right-hand side shows that we were able to recover core from about 14 times the height of the Eiffel Tower from beneath the seafloor. So that's about 3 kilometers of water and about another 1.5 kilometers of rock. And we can collect these amazing samples of underwater sediments that contain things like these amazing fractures that you can see in that central image. And we use that to understand things like tectonics in the oceans. And then lastly, if you were here at Scripps, there are lots of opportunities to go to see these images of the fleet that is operated by Scripps Oceanography. So we have 2 global class research vessels, the Sally Ride and Roger Ravel. And we also have a collection of smaller ships, the Sproul and the Beister, that people use to do experiments more locally here. And then lastly, we're designing and developing the first ever hydrogen-powered vessel, which is going to be coming online hopefully in the next decade or so. So if you were to come to Scripps, there's a good chance you could be doing some science at sea. If you don't fancy going to sea yourself, then you have the opportunity to work on those data with your advisor. Okay, that's it. I'll leave it there.
Excellent. Thank you, Ross. For seismology, over to Elise Gabriel.
Hi, thank you. My name is Elise Gabriel. I am representing all of the seismology faculty we have at IGPP, and I'm starting with this picture of one of the most famous textbooks, Introduction to Seismology. That's actually written by our current director, Peter Shearer, But next slide. We really are much more than the introduction to seismology and classical array theory. If you could click next slide. Ooh, yeah, sorry. We have these, we're dealing with very large data sets for large N analysis. For example, you see all of the US array data here that's being used for observational seismology or large N nodal array data on the bottom. We're interested in offshore DAS and array observations from the observational seismology side. And we also have a very strong part that's interested in computational and theoretical seismology using high performance computing, machine learning techniques. So we're going far beyond of what's covered in this textbook. That's the pitch. So next slide, please. I wanted to add some recent highlights. We have, for example, a lot of cross-IGPP collaboration. So this is, I'm relatively new here, but this is really something that's amazing, that a lot of different faculty is working together. For example, we have a joint study on the 2023 Turkey earthquake doublet that is shown on the top, where we've combined observational and computational seismology to unravel this earthquake doublet. More recently, we also studied Noto, New Year's Day, earthquake, and tsunami. So we're also interested in tsunami simulations. So it's a very collaborative spirit. And the second point is that we're also involved in many interdisciplinary and large-scale community efforts, and students that are joining us would be integrated in these too. So that includes this statewide California Earthquake Center, Crescent, which is the Cascadia Region Earthquake Center, SC40, subduction zones in 4-dimension, computational infrastructure geodynamics, and QuakeWorks. Next slide. These are the potential seismology-affine advisors and projects for next year's admission, or for this year's admission to come here next year. There's Gabi Laske, who's an observational seismologist, and I just took this directly from the website that maybe somebody can put in the chat where all the projects are described. Venyan Fan, who's observational seismologist, Peter Shearer, myself, and Yuri Fialko. But then for my last slide, oops, if you're coming, we are actually many more that are interested in seismology, even if they're not listed as looking for students directly. So these are many more faculty that are using seismology or that like seismology and that would be happy to work with students that are signing up for seismology projects. And I think I don't have time to read all of them out, but it's a lot and a very diverse set of faculty, reaching from science communication experts to heavily theoretical seismology to really data crunching and looking and going into the field and installing DAS cables and using drones and using all kind of new ideas for instrumental seismology. And I stop with this. Thank you.
Great, Elise, thank you so much. You can see everyone in the chat. Dave has put in the link that Elise was referring to on everyone's work. So over to Helen Fricker to talk about polar science at IGBP.
Sorry, great, thanks, Adrian. Yes, so this is I just wanted to give you an overview of the work that we do in IGPP, but also beyond IGPP, because we have this Polar Center. It's a center without walls, but I'm in IGPP and I'm the lead of that center. We bring together scientists and students from across the whole of Scripps to solve interdisciplinary problems related to the polar regions. And this is just yesterday, talking about tipping points, a Halloween scary theme. It was very fun in the Monk conference room. So next slide, please. Okay, so what do we do? The big picture is we're monitoring the ice sheets, and I'm just showing Antarctica here. And we do that in several ways. The big way is because they're so fast, we use satellites. And so many of us are involved in satellite and ESA satellite missions. So laser altimetry, radar altimetry to track the changes, and also GRACE and SAR, many different ways we can do this. But then we also go in the field and look at places that are changing, and we take geophysical techniques to try and understand the processes that are driving the change. And so the next slide will actually show some examples of 3 IGPP students that came through this program. So Jeremy on the left, Jeremy Bassis, he's now a full professor at University of Michigan. And then Chloe Gustafson on the right, using EM to found groundwater under Antarctica. She's now a scientist at the USGS. And then in the middle, Sushil Adesumili, who used satellite data to look at basal melt rates under Antarctica. And Cecile has just started a faculty position at the University of Oregon. I should say Jeremy used seismology to understand rifts and how they operate and how they propagate. Next slide, please. Okay, great. So there's opportunities for field work. Maybe international, and Jamin is on this slide as well, bottom right, with his team. He collaborates with the Korean Polar Group, and also we both collaborate with the Australian Antarctic Program as well. We also go down with the US Antarctic Program. So this is all Scripps students and postdocs and others doing fieldwork in both polar regions at different times of the year, obviously. So many opportunities for that across the whole of the polar regions within Scripps, many different techniques as well. Yeah, move me on, great. And then this is this is a big thing. It's a concept study that we're in phase A for a satellite mission. And if this gets funded, then this will open up a lot of opportunities within IGBP. I'm the PI for this mission. It's a new satellite altimeter. So I'll stop there. I think I've already been 3 minutes, and I'll take questions later, maybe.
If you want to talk about this, go right ahead.
Do I have time? I forgot to put my timer
Yes.
on. Yeah, so it's an innovative sort of continuation of currently orbiting satellite laser altimeters. We have JEDI on the space station and ISAT-2 in a free-flying orbit for the polar regions. And EDGE will take that together. It will take the JEDI technology, add more beams, put it on a free flyer, and map the vegetation and the ice at very high resolution. We're very excited about it. We have a lot of work to do to get it launched, but if all goes well, it should launch in 2030. So watch this space.
Excellent. Thank you so much, Helen. So over to Vashon Wright, who does, well, we're going to call it soft Earth geophysics, and he can explain what that actually is.
Thank you. So we do what we're calling soft Earth geophysics, with the recognition that on Earth, it looks like we live on a soft matter landscape. If you think about soils, muds, ice, and rock, they mostly exist in this fuzzy space between acting like a solid and acting like a liquid, depending on the timescales being observed. And if you go to the next slide, we'll talk about the importance of that. It turns out that 70% of the solid Earth comprises of these soft, squishy, amorphous material that don't have this regular ordering, and that a lot of the hazards and the processes in Earth, whether it be ice shelves collapsing, magmas being filled with crystals, slope failure, pyroclastic density currents, liquefaction, or even inside the gouges of earthquakes, or how we understand past tectonic. It's about how these soft, squishy materials deform on various timescales. If we click the next slide, understanding what is controlling their flow is very important for all of these things. And so what my group does is recognize that the Earth is actually made of soft matter, and as a result, using tools from soft condensed matter physics to understand the flow of Earth materials might actually help us understand hazards a little bit better. If we go to the next slide, and so essentially what we do is we test and expand current soft condensed matter physics theory or granular physics theory, really trying to understand what's controlling natural hazards. Oftentimes we have a theory. That theory makes some phenomenological predictions. It says this is what we expect to happen. We use lab experiments and field observations to test those theories or improve or propose expansions to those theories. And if we get those theories right, we'll be able to forecast and understand several different natural processes and hazards. If we go to the next slide, I'm just going to talk about 3 things that we're working on right now and where there are opportunities for new grad students. We've been working on landslides, which really integrates control source seismology and near surface geophysics techniques with soft matter physics techniques and lab experiments to improve our ability to forecast landslides. And for any physicists in the room, one of the things we're looking at is the density of states, and whether or not that's actually a good predictor for failure. If we go to the next slide, the other thing that there's opportunity for is to look at Caribbean tectonics. In the Caribbean, there's a paired strike slip system. And we're planning cruises in the next couple years to understand how the rheology of the system. And so Ross talked about going on the Langseth and getting reflection seismology data. We're trying to understand how the rheology and the inherited crustal structures are influencing how strike slip fault systems are interacting with pre-existing faults and what that means for seismicity. And then the last opportunity within this group is we've been focusing on using rock physics and classical seismology, whether it's the seismic velocity and gravity, to determine whether or not Mars hosts liquid water. We just published a paper that suggested there's liquid water in the mid-crust. And so testing and expanding upon that idea is also something that's available. That's it.
Wonderful. Thank you. So I'm going to say two words about geodesy. I realized as I was putting this deck together that we do, hang on while I, okay, can you hear me? Okay, excellent. I shouldn't have left this out originally, but really quickly. So geodesy, which is deformation of the solid Earth, is something that is sort of near and dear to many SO geophysics faculty. We use various technologies, GNSS, which is a global positioning system, more broadly RIT, and interferometric synthetic aperture radar to study the earthquake cycle, to study the water cycle, atmospheric climate, pressure systems, and then a whole different set of technology at the bottom, which involves marine or seafloor, seafloor geodesy, changes and in the bathymetric depths that are usually related to Earth processes. And then a whole set at the right, you see this globe, so a set of using satellite altimetry to see how the sea surface is changing, actually sea surface heights, how they change both in space and time, which gives us all kinds of interesting insights into the oceans and into the solid Earth underneath the oceans. Additionally, and this is the main reason why I wanted to bring this out, our land side of the going to the field has often involved geodesy. We go almost yearly, if not more than that, and certainly when there are large earthquakes, essentially everyone deploys from Scripps and from IGBP. Okay, that's all I'm going to say about that. Over to Dave to talk a little bit about the geophysics graduate program and what you might expect if you were to arrive.
Thanks, Adrian. So we've heard a little bit about all of, or some subset of all the exciting science that's conducted in IGPP. And what essentially I wanted to do was give you an overview of what you would be doing as a graduate student here over the duration of your time as a graduate student, and then focus more specifically on what your first year would look like. Next slide, please, Adrian. Yeah, so it's 3 parts. What the timeline looks like, some specifics of first year regarding the courses, and then some application-specific information. Next slide, please. So we have essentially a 5-year program. In the first year, essentially what you would be doing is a combination of classes and research with a more time weighted towards the classes. So maybe something like 80% classes, 20% research. In your second year, that sort of ratio would transition a little bit, sort of switch the other way. So you do more research, maybe something like 70%, 30% classes. In your third year, you would transition into what we'd call here as full-time research. So probably you're not taking any classes anymore, and you're spending all of your time devoted to your research activities. And in fourth year, same again. Fifth year is when we expect you to graduate, defend your PhD and graduation. And so in all years, SIO and UCSD will require you to enroll in 14 units. And there are units associated with classes, and there are course units associated with research. Okay, so you're always enrolled in a certain number of units. Some of them are coursework, some of them relate to research. There are a couple of important milestones in this sort of 5-year timeline. The first is at the end of year 1, you sit and pass a departmental exam. That is something that we run in geophysics, so it's geophysics specific. I'll say a little bit more about that in a few slides. At the end of year 3, you advance to candidacy. And then at the end of year 5, that's when we expect you to submit and defend your PhD. This sort of program, this 5-year program, and all the guidelines associated with it can be found. It's documented in this SIO PhD student handbook. I'll post some links to that in the chat when I finish talking so people can refer to it later. Next slide, please, Adrian. Right, so in the first year, specifically your first year, the things you would be doing in general are you'll be consulting with what we call a guidance committee, which consists of your mentor, your nominated mentor, and the committee or group of people in IGPP responsible for preparing the departmental exam. You will consult with them on matters related to the courses you should take, any issues you might have in transitioning from being an undergraduate student to a graduate student. And they're really, this serves as a sort of support network for you to help make that transition from student to graduate student researcher. You'll take classes, you will learn in those classes how to conduct research, and you'll learn specific things about geophysics, and then ultimately you'll be commencing research. And then at the end of the first year, you'll sit this departmental exam, which consists of 2 components, one related to a written component and an oral component. Next slide, please, Adrian. So what would your first year look like? In terms of courses, here is a listing of classes that that are available, and that some of which you are strongly required to take or encouraged to take, and some which are elective. So the blue or the pale blue-gray ones are what we call foundational classes. These are the classes that would be covered in the departmental exam. So they're not, they're foundational for a reason. We think they're very important, and we examine you on them at the end of the year. So those ones you have to take. And the ones that are in black are the electives, which we also encourage you to take throughout the quarters, which are sort of the 3 quarters separated there by a large white space. So you can see there are classes related to geophysics, classes related to physics, classes related to mathematics, classes related to data analysis. The reason we have this kind of broad smattering of material is because we're highly interdisciplinary. We value our faculty as interdisciplinary. We value interdisciplinary research. So we train you in all of these interdisciplinary topics so you're well-rounded and fit within our interdisciplinary ecosystem. Next slide, please, Adrian. So your support team is essentially your mentor, the curricular group coordinator, Maddie Morsfeld, who takes care of the program in geophysics, and the 2 or 3 people in the departmental committee who basically manage the first year cohort and prepare the departmental exam. So you have a large number of people there to help you navigate the process, the system in GP, in SIO, in UCSD, all of these layers of the hierarchy. And you meet with them often, right? There are lots of people you'll have lots of opportunities throughout the year to interact with the committee and the curricular coordinator. They're there just to help you succeed actually in your first year and in subsequent years in graduate school. Next slide, please. Okay, so studying at Scripps, this is my last slide. Essentially, we provide something that's we regard as a structured curriculum, gives you the foundational knowledge in geophysics and theoretical geophysics. You have access to a broad range of specialized and interdisciplinary courses. If you come here, you could take advantage of some of the field and seagoing projects that Ross and Adrian mentioned. We have great computational resources and skills within the faculty here to help broaden your research opportunities or perspectives related to computation. Scripps is huge. It's the largest department at UCSD, and there's something for everyone here. So you have a diverse range of potential colleagues, friends, collaborators, and research opportunities. And so if this sounds like something that's appealing to you and you want to join our institute, I will remind everyone that the closing date is December 4. You should explore the geophysics pages. We're going to send you this slide deck afterwards where that link will be able to be accessed. And we'll send you also at the end of this meeting, everyone that's registered, we'll send you some information specific to the admissions process to help kind of make it a bit easier to navigate for you. And so you can send in your applications more easily if you're interested in coming here. I think that's all for me, Adrian. Thanks.
Great. Wonderful. Again, probably this will be a section that has a lot of questions on your mind, so jot them down either in chat or just hold on to them for the Q&A. Our last formal segment is the student experience, and this is Madeline Kerr. Go right ahead.
Great, thank you, Adrian. Hi, everyone. My name is Madeline. I'm a fifth-year PhD student at IGPP at Scripps. Next slide is good. So the graduate student body sort of fluctuates every year, but there's roughly 70 incoming PhDs and about 10 incoming geophysics students per year. So there'll be a lot of pictures on these slides, so you can see like little snapshots of activities and things people are doing, groups and such. On the upper right is a departmental exam themed study session where we did charades at the end to help people remember different ideas. So, you know, we have fun. Next slide is good. So there are a lot of IGPP specific activities that happen throughout the year. One of the pictures here is the fall equinox, sort of monk building alignment where the sun sets right down the hallway and it glows the whole hallway, this wonderful orange hue. And it's a lovely time to just be around people and to see wonderful things, just space, building, architecture. But in terms of just like hard facts. So the Keller, as Adrian noted in the first bit, is the GP first year office, and it's below the building with an ocean view. There are coffees, tea times, mock oral exams. There's a lot of resources that geophysics representatives like basically create to help like get a sense of community going and also to help you throughout like all of the coursework and all the exams and qualifying and all of those different steps. So we're quite interconnected and quite tight-knit. A new thing that we have is IGPP scavenger hunt, which people like the GP reps sort of organized a way to get to know the whole IGPP building scape. So that's in like the bottom left corner. There's camping trips. There are weekly technical seminars and student lunches, as well as seminars for specific project groups, like the Polar Group also has seminars that happen, I guess, monthly. I'm not in Polar, so I'm not sure, but there are a lot of different opportunities to hear scientists talk, either in the department or visiting from other places. So next slide, it's good. So there are a lot of ways to find community at Scripps and at IGPP. I am here because I am a member of the graduate professional, or I'm a member of the graduate student council, and I'm the GP rep. But you can even do like student council work in the larger UCSD community, which is the Graduate Professional Student Association. You can be a part of the union, so graduate students here are unionized to help increase pay and also just like provide a support network for any situations that happen while you're doing your PhD, so you can become involved in that. There's SCOPE, which is a community outreach program that sometimes leans more into the marine biology and atmospheric science stuff, but they are open to people in geophysics participating in that. So if you'd like to do that, that's definitely an option. Yeah, so department opportunities, faculty hiring committees, curriculum review, GP reps, which is not what I am, but there's a separate group that organizes events and helps people through the year, and SciChat, which is a geophysics like PhD grad student run sort of informational like presentation session where people can present on topics related to their research or just in general anything of interest that would be helpful for like incoming younger students to know. There's also a peer mentor program. So like first years get like linked up with someone who's older, and then they can take them out for coffee, like show them the ropes and such. And then there are also larger Scripps opportunities. There are DEI fellows, there are SIO committees, there's like a huge list of them. And if you have any questions about those specifically, you can reach out to me because there's like 10 of them on the SIO website. And then there are also like affinity groups like Queer at Scripps, which I've participated in somewhat. So yeah, next slide. I brought this up because Ross brought this up earlier, and I just wanted to reiterate that even if you're not doing research that's fieldwork related, there are always opportunities to participate. I've participated in 2 research cruises, even though I just do like computational, like mantle convection modeling. But I really wanted to take advantage of being at Scripps. So I've been on 2 cruises. And so there are some pictures here of some field work. And then the bottom right corner is me helping to deploy an ocean bottom seismometer in Samoa. So, you know, you have an opportunity to do a wide variety of science and meet a lot of really wonderful people along the way. So yeah, next slide. So living in San Diego, I think like the one asterisk is that it's expensive in San Diego. Rent varies by neighborhood. So on the SIO, so there are ways to find housing. You can use the housing listserv, which you can like when you eventually become a student, you can get access to. There are Facebook groups, and there's also graduate student housing, which there's a website for graduate student housing. You can get on it. You can see the prices. The range is from like around $950 to $2,300 for a single occupancy room, but the mean is somewhere around $1,100 to maybe this is a little bit conservative. It's like around $1,500 somewhat. So it can be expensive to live in San Diego, but there are a lot of ways to make that easier, including cheaper public transportation. You can bike quite easily. There are buses and shuttles and everything, and there's a nice trolley that takes you downtown. So living, you can live sort of at different shells outside of the immediate La Jolla UCSD community and still be able to access the campus easily. So next slide. So yeah, in general, San Diego's a wonderful place to live, and Scripps is a wonderful place to work. Like Adrian brought up, there's wonderful surf break right off the coast of our building. There's wonderful hiking trails, there's rock climbing, like inland and also in gyms. Lots of people do cycling. There are a lot of wonderful people to connect with because it's quite a big city and it's Southern California. So you'll have wonderful weather and yeah, good music, good food, great beaches, and it's a safe and convenient place to live overall. So yeah, that sort of closes out. I think there's one more slide. Yeah, these are just pictures, but I will say that this is like sort of an information overload. So if you have any specific questions, you can please, you can email me. I'm gonna put my email in the chat right now. Yeah, you can email me with any specific questions you have about potentially being a graduate student at Scripps, anything you're worried about. I am a graduate student, so I don't have to like say that you asked me a question about a specific thing. So feel free to reach out if you have any particular questions. But yeah, thank you so much. And with this, we're going to go into a Q&A session. Adrian will be helping answer the questions, and we'll all be here to sort of facilitate this information. So yeah, I'll give it to Adrian.
Melon, that's great. Thank you so much. So those of you who are so inclined, we would love to have your questions in person. You can raise your hand. It will pop right up to the top of our Zoom list. I'll call on you. You can also drop questions into the chat, and I have one that's ready to go already.